Hello everyone, welcome back to our channel. Today we are dividing into data preparation with Python, an essential skill for data scientists and analysts. Whether you are amazing a raw data or preparing it for analysis, this technique will save your time and improve accuracy. Let's jump right it now. So the first one is adding an index field. Our first task is that only to add index field to your dataset. This helps you uniquely identify each records. Get to know how? Let's see. Let's see by you having an example that how the index field is added. See, first we have imported as panda and given it as the name PD. So as it is written as comment here also, the sample data, we have the data as keyword and the different entities here as the name we have provided Elias, Bob, Charlie. So we have provided the list of names here. Okay. And the age, we have provided different ages for Elias, Bob and Charlie respectively. Next one is the def keyword. We have put it as using the function pd.dataframe data. So this data holds this much values or this data. So it is now inside the df. Now if you want to get the index of any data here from this Charlie or the index value for the Elias or Bob, how can we have it? Let's see. So df as it contains the whole data here and we have used the symbol for or we can say the words index. So which index we want to get? We have provided the range from 1 to length of df. It has all the data values now plus 1 and we have printed df. So this will provide the index value of the data which one you want to run this in voila. Each record and has its own unique index. Super handy for amazing data sets. So this will provide you the index of the everyone, every data will. See? So now let's jump to the next topic that is changing misleading values, field values. Na? How the values are changed. So this is especially very useful when you have inconsistent or unclear entire entries in your data. No? That for inconsistent values you will get to have in your data. So how will you handle them? By using the dot replace function, you can quickly clean up misleading values. Now your data set is much cleaner. So let's see example for this, how we handle the or change the misleading field values. Let's see example data status. It is holding this much the list of values and we are how these are replaced by this. As you can see yes, no, maybe or NA. And if you want to replace this status replace dot replace. We use the dot replace function for replacing that values. Confirm no, denied maybe. So these values are now replaced from them to like this. From yes to confirmed or no. And we can print this. Now let's move to re-expressing category. The third point, re-expressing categorical fields. So what is this? What is re-expressing categorical field value? These are crucial for machine learning models with often require numeric data. Here's how to encode these categories. In just a few lines of code, we have converted text categories into numbers, making them ready for machine learning. Want to see example? Okay, we are having example also. So from sklearn dot processing, we have imported the label encoder for the further use, and we are having a set list of values here as A, B, A, C, and we have put them in a category. Now encoding the categorical values, how they can be encoded. We are using the category code encoder.fields. This is a function of the label encoder. How will we use it? Like this is the code for it. Encoder.fit transform df category, and then print with df. The category of the data will be printed here. The next one is standardized numeric fields. Standardizing numeric fields helps brings all your data to same scale, which is critical for algorithm like K-mean and logistic regression. K-mean you can see it is also much important in data science. So this ensures all values have a mean of 0 and a standard derivation of 1, making them easier to compare. So let's see example for this. Here it is. We have for this also we have to import the module that is standard scalar. As without this we can't use the functions of this standard scalar. We have a set of values and the list of values, and it is in the inside the data variable. So we have used the PD as the name pd.data frame and the data. So data, these values are now stored in this. Now we are standardizing the values. So we have given the scalar. This is the function for the standard scalar. Standard scalar. DF. We can put the standardized value. Which value we want to standardize that, and here the value that is transformed or that is changing. Okay. Now move to the last one, that is identifying outliers. So identifying outliers. And there you, with just a few calculation, you can easily flag outliers. Here's how to see value of 100 and an outlier based on its Z score. I will provide you the example here. Those data points that don't quite fit, we will just use Z score for this. So the values that we just want to quite fit anywhere we want. So we can use that Z square. Let's see example for it. We will be understand more easily. So identifying outliers. We have imported the numpy as np. We will use it further by the name np. And data values, the list of values. Df, we have provided that data is stored in the df variable. And now we are calculating now the z score. Df, the z score that we want to calculate, the value, any value from here that we want to calculate, df mean, then the same value we have to put in the place of this value, and we will print the df. The output you will get will be the z score value. With just few calculations only, you can easily flag outliers. Here we can see the value of 100 is an outlier based on the z square. And there you have it. 5 powerful data preparation techniques in Python, from adding index field to identifying outliers. These skills will elevate your data workflow. If you found this helpful, don't forget to like, share,